Hi everyone, the purpose of this video is to very briefly talk about how I figured out the structure of this compound C7H14O2 using the IR, CNMR, and HNMR data that I was given. So I was given C7H14O2, and I first calculated the degree of unsaturation by using the formula and removing the N and X or halogen aspect of it because there are no nitrogens or halogens in this formula. This left me with 2C plus 2 minus H divided by 2, which I then simplified to 14 plus 2 minus 14 divided by 2, which is just 2 divided by 2, or 1. This means that the degree of unsaturation is 1, which indicated that I had one double bond that I was dealing with. We know that this wasn't a ring structure because there's nothing in the IR spectrum to indicate a ring structure, and there is a CO double bond indicated in the IR spectrum at around 1700 centimeters to the negative first power. So to analyze the rest of this, we knew that there was a CO double bond. Looking at the rest of it, we see at around 2900-ish, I wrote down a better answer in my data table, but around 2900, we see sp2 and sp3 hybridized carbons, or those represent some CH bonds. We see the other CH bonds here, as indicated in the table. That would be the bending CH bonds, which are at about 1450. We see a CO bond, and we see single carbon bonds. Now there's a CO stretch at around 1025, like I said, and that indicates that we have a CO double bond and a CO single bond without any OH because there's no oval type shape up in here, which would indicate an alcohol. So there's no alcohol, which means it can't be a carboxylic acid, and so it has to be an ester. So we have to have an R group with a carbon double bonded to oxygen with a single bond to oxygen and then some other R group. So that's how I knew I was dealing with an ester. Moving on from there, I knew that I was dealing with a carbonyl group because we knew that it was an ester in some way, shape, or form. So this is the ester carbonyl, and that's indicated around 173 or 172, somewhere in there, ppm on the CNMR data set. We also saw around 60. There is an OCH2 bond. This is the carbonyl group, and this is basically just saying that there was a CH2 attached to the carbonyl, and this indicates that we had some CH2 and some CH3 groups as well. So this all supports the notion that we had an ester. This would just mean that a CH2 is attached right here. We have an OCH2, which all supports, this indicates this here, and this indicates this here, my bad. And all this data is recorded better in the data table. I'll show you that. Then we take a look at the HNMR diagram, and we see that we have different data points as well in here, which are better reflected in the data table, so I'm just going to go ahead and show you that. So we notice that around a chemical shift of 4, we had an integration of 2H, a multiplicity as a triplet, and that's written down. These are written down incorrectly. I apologize. I just noticed that. But so these, focus on the data table. We see that we have about 6 key moments because 2 are going to be the same with our CH2s, and the primary things that led me to my ultimate answer were the IR spectrum and the 13C NMR spectrum. And all of this just records the same thing that I explained over here, but what we see right in here is that this is basically when I wrote down exactly what we came up with based on this data, all of the data. So we ended up with one carbonyl, which was reflected in our IR spectrum, in our CNMR spectrum, and in our, where is it? So sorry. In our O spectrum right here at around 1.1 ppm. And we saw that we had one OCH2, one CH2 next to the carbonyl group, two internal CH2s, one CH3 on the butyl end, and one CH3 on the carbonyl end. Then I took those steps and I wrote them out, and I just kind of started to piece it all together. So I said, we have one carbonyl group, so let's write that out first. So we had a carbonyl, and I knew that it was double bonded to we knew that it was bonded to a CH2, so we just said, okay, let's just represent that part first. Then we have one CH2 next to the carbonyl group, so that would be over here. One CH3 on the carbonyl end, so we know that would be right there. Two internal CH2s, so I added those over here onto the butyl end, and then one CH3 to terminate the molecule here at the butyl end. So 1, 2, 3, 4 carbons, so this is the butyl end, and then 1, 2, 3 carbons, so this is the carbonyl end. And we can see that this ultimately was a straight chain. There was no branching off indicated in the NMR spectrums, nothing like that. So we know that it was a straight chain, which would mean that it was an N isomer. So ultimately this is the configuration and the, the structure that I came up with, N-butyl propianoate. And it's an ester that has 7 carbons, 14 hydrogens, and 2 oxygens.